Every challenge question, part 14. This is the chapter about differentiation, doing some first principles here. So f of x plus h is 1 over x plus h, I guess, in here, like this. So this is the setup for here that we'll use. Let's combine these fractions together by tiling this one by x over h, and this one by x over x. And then we, of course, get the same denominator, but x minus x is nothing. So we just end up with minus h on the top. And yeah, this h here actually can combine with this bit here. And therefore cancel with this h here to leave a minus 1. And as h goes to 0, this thing just becomes an x, so you get minus 1 over x squared. And I think that's that job pretty much done. Good. Second question. L is tangent to this curve and meets the y-axis minus 8. So let's draw a picture of this information. This is a U-shape with y-intercept of 1, like this. The tangent to the curve cuts the y-axis at 0 minus 8, which is down here somewhere. And so it looks a bit like this, maybe, tangent up here somewhere. Positive gradient, of course, so it could be this one, but it's positive gradient, so it's this one. Find the equation in L. Now, this is an interesting question because I didn't actually use any differentiation, which is what this chapter is supposed to be about. I'm not sure whether I just missed something, but anyway, this is the line y equals mx plus c. It's got a y-intercept of minus 8, so we can immediately put that information in. And now all I did was I looked for, of course, if it's tangent, then that means when you solve it against the curve, it just has one intersect, which means b squared minus 4ac is 0. So I just set this equal to this, and then when I wanted to get to the thing, I just said b squared minus 4ac must be 0, and therefore I can solve for m by setting up that equation, which gave me m was 12. Of course, it could be minus 12 because positive gradient, and then of course you just put this thing in here. So yeah, no differentiation required, which is kind of interesting. I also think even if you did use differentiation, this is probably easier. I don't know. Find the first 4 terms of this. Well, okay, so sure. Good. Hence proof from first principles derivative, that is that. So let's get out that same definition we used earlier, limit of h into 0 of x into x plus h minus f of x over h. F of x plus h is this thing, at least up until the first 4 terms. And f of x is just x to the power 7. So let's put all that in. And now this x to the 7 cancels with this x to the 7, obviously. And when you divide each of these terms by h, this one becomes 7x to the 6. This one becomes this with an h on the end. And then this one, this with an h squared on the end. And everything else that I've skipped over here has more h's in, right? So when you divide by h, you still have an h left over. So it's h into something. As h tends to 0, all of these terms go away except for this very first one. And we end up proving that thing, I think. Oh, that was the entire thing. Wow.